we have seen the different types of data, and what you have to remember basically about the different type of data is just that you can have quantitative and qualitative data, and you can have different level, let's say, of power of the measurement that you can make on this data. So you can do, and this power corresponds to different mathematical operation that you can do on the data that you collect, and of course different statistical analysis that are allowed on this data. Now we see which are the typical data collection techniques in software engineering. You will see that there is a long list. Okay, as it's written here, before measuring the data, you need to collect them. Okay, and you need to collect them in a way that is relevant for your research question. That's why I started in last lecture from research questions. Okay, because anytime you search for some data, it has to be linked to the research question. Okay, the data collection technique is, of course, guided by the research question, but it can also be guided by your specific context, because you may have a curiosity for research, for a certain research, but you may not be able to access the environment, the relevant environment, to gather the data that are needed for you. So you have to consider also your context, your reality. So are you in contact with a company and you can interview people directly in the company? So you can take some time from this company, from the employees, then it is good to interview them. So you can select the method, the data collection method of interview, because you know that you can ask employees and developers for that time. In another case, you may be in contact with the company, and you are able also to take some time in which you gather more subjects altogether. Consider that this is very difficult, okay? Because even if you are a researcher or a student, you get in contact with some industry, with some software industry, it is very difficult that you are able to ask them to meet in a focus group for 1 hour or 2 hours, because they have to stop their work. Okay. And but if you're able to do that, it is good to have a meeting, because you can observe data related to the relationship between the people, for example. But you may also be in a situation while you do not have any direct contact with companies, but for example, your professor has some contact with many companies. So in this case, you may better use a questionnaire. Okay, so send questionnaire or survey. I will use these terms as synonym. Okay, in this class, and so you don't have the direct contact with company, but someone else, or like you can create a network without reaching directly the people. Okay, and or you may be in another situation in which your research question asks you to compare the performance of different tools, but for a certain task, for example, for testing or to facilitate debugging, for example. But you have to consider also, do you have the licenses for this tool? Can you buy them? Do you have the money to invest on them? In this case, if you can do that, probably the data collection technique can be to apply some static and dynamic analysis of the system. So we will see more about this type of data collection techniques that are here are just words for you, like interview, focus group, questionnaire. Now we will see them more in detail. But the most important thing that I wanted you to notice in this slide is that reaching the right source of information is one of the hardest parts. Because let's take the case in which you want to do a survey and understanding and having a reply, a survey, and you don't know any company. You want to do a questionnaire, you don't know any company. Having a reply from the right people is very, very difficult. I will give you some numbers also later on. And also internally to a company is even more difficult, because you need to create a rapport with the people. You need to create a good relationship if you want to do interviews with them. Okay. This is a list of data collection techniques. The list is from 2005, and you can check in this paper here. And the list is very long, as you can see. So there is a large variety of techniques. And we will see them. We will have an idea of most of them. And then we will see also in the next lectures in detail something more about interviews, questionnaires, and maybe if there is sometimes about mining software repositories that is related to static and dynamic analysis of systems, because this is from 2005. The article is very complete, but some name changed because some trends in recent literature and technologies have emerged in latest year. I will point to you to the new, let's say, term to refer to the same old things. Okay. The data collection techniques are normally distinguished into 3 degrees. The first degree technique are the one that require a direct involvement of software engineers. So software engineers have to make some sort of effort, or they have to interact directly or indirectly with you, for example, through surveys and questionnaires, to gather the data. The second degree technique, they are the ones that have an indirect involvement of software engineers. So you are evaluating somehow the software engineers, but you are not interacting directly with them. And in some cases, the effort required to them is not too high. The third degree technique are the ones in which I study just the artifacts. Okay. I don't involve people. I don't care. I may care about them, but the trace that leave people are the only thing that is relevant to me. The trace that leave people in the system, of course. And in this case, I can avoid the interaction with the actual subjects that are in general developers. Okay, because software engineering is studying all the subjects that I listed in the previous lectures, but of course, most of the time we are dealing with the data produced by the developers, because the code is one of the most relevant things that are produced in the software process. So let's see this picture that gives us, instead of a list, a more dynamic view of what this technique entails. So the first degree technique are more people intensive. So you need to involve the developers or the people in general. And since you involve people, they are less reliable. Any measurement made with people is less reliable. Then you have to consider that they are also more flexible in general as data collection techniques. So you have less strict way of collecting the data, and they are normally oriented to understand the things related to cognition. Since you have access to people, you want to access things that you cannot get from their code. So you want to get things that are more human oriented. So cognition, but also emotion. For example, in recent research, there is a trend about emotion in software engineering that you may consider not relevant, but for example, when if you've been developing code for some time, you understand that there are moments in which you are just in flow and you are just programming and you don't pay attention to time, and times in which you are completely frustrated, get stuck on a bug, and spend a lot of time on the bug. Understanding this type of dynamic is as relevant as understanding the bugs in the code. So they are studied. There is some experiments made with different devices, for example, this wristband, that professional wristband, but also eye tracking and electroencephalography. So several studies in this direction. So cognition, but also emotion. So if you need something that is missed here, these people-intensive technique are like brainstorming, questionnaires. You need people. Okay. Second degree technique, you need people, but a little bit more, because you have an indirect intervention. And data intensive technique, as I was exemplifying, you need lower resources, because the resources are just the software, okay, but you have a lot of data, okay. You have a lot of data, and this means that you are also focusing on you also have to deal with this aspect. We will see some issue related to the large amount of data that you have to deal with later on. And these data intensive techniques are more related to behavior than to cognition, because you are observing the data. So you are either observing the trace that people leave in the software, or in the interaction with the system, okay. So let's see now each technique one by one, okay. Here we start with the first degree techniques. First degree techniques, as we said, require direct involvement of the software engineers. Software engineers mean developers or anyone, okay. The yellow one is the software engineer. The blue one is the researcher, okay. The researcher, or another software engineer who is in charge for understanding how things work in the company, okay. There are two main categories. One is inquisitive technique, and the other are observational techniques. In the inquisitive techniques, you participate you actively participate in the collection of data, okay. And there can be like interviews, questionnaire, conceptual modeling, and brainstorming and focus group. In the other case, you have less participation, because you are present, but from a distance. And for example, you can be an observer of the software engineering in the company. We will see some example. Okay, observational techniques are these three: think aloud, shadowing, and participant observation. Okay, let's start with the first ones. Okay, with brainstorming and focus group. These are first degree technique, inquisitive. Okay, basically, what are them? Based on a simple trigger question, people are free to express whatever comes to their mind, initially on paper, and then take turns to speak. For example, let's say I want to understand. I am in a company and I want to understand what are the problems with the management, for example. Then I do a focus group in which I involve the developers and the testers, for example. And I ask this simple question: what are the main problem with your management? Okay. And these people are asked, for example, for 5 minutes to write down the most relevant problem in a small piece of paper. And then they are able, each one is able to speak, and the one can provide their own viewpoint. This is also a way of collecting data. Okay. When we speak about data collection, we speak also about these techniques. What is the advantage? The advantage is when you don't know so much about a domain, about a context, and you need some ideas, some first fresh information. And as in the case that I showed you, as in my example, they allowed you to rapidly identify what is important and what is not for the people. Okay. And it allowed, if I ask, for example, to people what are the problems with the management, the feeling for the people is that they feel really involved in the research. Normally you ask and they are very receptive in this type of context, because rarely developers are asked about this type of issues. Okay. And they're always eager to say, everyone wants to say their opinion. Okay, we know that. The disadvantages is that they can become unfocused, because of course a discussion, it has limited time, can be superficial. There can be some dynamics that lead someone to speak a lot and someone not to speak. So you have to be very well organized and very careful. There are entire books on how to carry out a successful brainstorming. And there are professional, of course. The key here is that the researcher or the person that guides the group is someone who know how to talk to people, how to organize people, and not everyone is made for this type of job. Okay. And on the other hand, there is the thing that they are often hard to schedule with busy developers. As I said before, it is very hard that you can gather people, create a focus group, and distract them basically from the daily activities. Okay, here you have an example of an actual study that was performed, and this in the slide, I mean. And here the goal was to understand the factors leading to success and failure of software process improvement. So this researcher in this real study were involved in 13 companies, okay, 13, so quite a lot, and implemented 49 focus groups, okay? And they had 4 to 6 participants, and each session lasted 90 minutes, okay? These groups had different type of people, and from this focus group they moderated the focus group, and they gathered 90 minutes, so quite long, 1 hour and a half, and they gathered all the information to success and failure of the software process improvement. Of course, processing all this data, this was gathering the data, but imagine processing all the data would require a lot of time, because this recording, it implies recording, transcribing what was said, knowing who was saying what. So it is not an easy strategy to apply and to analyze. Okay. So let's pass to the other strategy. So in this case, you have multiple people meeting. The other strategy, still inquisitive, is interviews. Okay, basically interviews is what you know. You ask a series of questions to some relevant actor of the software process, or in general, you ask relevant questions to someone and you collect the answer, someone that is expert on something. Okay, the advantages of this technique is that people are very familiar with question answering, so it is not something like, while in focus group and meeting, not everyone is in use of having this meeting, and there can be some different behaviors depending on the attitude of people. This is more limited in interviews, because people normally are based on dialogue, and the question answering is something common. Okay, again, also in this case, people tend to be happy when someone asks about them, so it's good also to create a good rapport with the people, with the developers. And another important thing that you may experience as the most important thing while doing interviews is the possibility to clarify things. Clarify means clarifying your questions, but also asking clarification about the answer that are given, because anytime you start an interview with someone that is doing a different job from yours, or that is expert in a different domain from yours, a new word opens up in front of you, a word of different terminology, a word of different rules. So you have to consider that a lot of time, especially in the first interviews, is spent in clarifying. Okay. The main issue with interviews is that people are not always reliable. So they tell you something, but in practice they do something different. For example, there was a study in which people that were interviewed, and they were saying, "Oh, we are spending a lot of time in documenting the code. This is one of the most time-consuming tasks of my activity." But then, when looking at the time that they were spending and the documentation that were produced, it was clear that they didn't dedicate so much time, and it was clear that the amount of documentation was very little. So if you just trust what they tell you, may not reflect the reality. Okay. It is also difficult in interviews to do sampling, so selecting the right people. Most of the time you are forced to select the people that are available for the interview. For example, you consider an organization, and just a subset of the people may be allowed to speak to you. Of course, it's time consuming, a little bit less than the focus group, but it's time consuming for scheduling the interviews, doing data transcription, etc. And for example, here there is an example of another study in which this researcher went to various organizations to study the software process, okay? And they involved, you see also here, they involved different subjects. In this study with people, it's very important that you involve different viewpoints. So not just the developers, but also the designers, the project manager, and the different level of management that you might have in the company, because all these people, they have different perspective, and very, very frequently they are opposite perspective, okay? And in this case, they conducted 97 interviews and 3,000 pages of transcripts is a lot, like a very large amount of interviews. Normally in an interview study, you do 20 to 30 interviews, okay? This is like a very large, very, very large study, and you need to involve a lot of people, and consider that 3,000 pages to analyze is not a joke, okay? The third type is questionnaire and surveys. In here, I use questionnaires and surveys as synonyms, but actually there are some differences, of course, because a survey can be performed through a questionnaire or through an interview, because a survey is actually a list basically of predefined questions to answer, and I can ask people to answer through web with a questionnaire actually, or I can ask people to answer directly, like the ones that come to you at the airport, for example. I want to ask you some, or at the railway station, I want to ask you some specific question, okay? But in our case, we speak about questionnaires and surveys as synonyms, okay? For us, they are synonyms, and they are written, predefined questions to be answered by people, okay? These are quick and easy to administer. This is the biggest advantage, and you can reach a lot of people, because if you put a questionnaire on the web, you may reach a large amount of people, okay? The disadvantages with respect, especially to interviews, is that it is difficult to clarify questions and answers, okay? So your questions has to be very clear in the start, okay? And you need to pilot your question, to test your question with a possible audience, because you may assume that what you write down is clear, but it's never clear the first time, okay? And I will give you a lecture on how to perform questions and questions in questionnaires, and how to administer surveys. Like I will give a lecture on how to perform interviews. Focus group are not part. We will not speak about them anymore. Okay, but about questionnaires and surveys and interviews, we will speak. We'll speak about them in other lecture. The other issue, the return rates can be low. Okay, if you send 1,000 questionnaires, you may receive 100 responses, or 200 if you are very, very, very lucky. Okay, so these are estimates for the software engineering field. In other fields, it's even lower, like around 5%. Okay, but of course, also for giving a questionnaire, you need to have clear already what you want to ask. While in interview, you can invent question while the interview develops. In here, you have to establish them. So you have to know a little bit more about your context. In this example, for example, you have this paper-based questionnaire that was given to people to identify factors affecting the adoption of a certain tool in 52 organizations. And what did they do? They knew who purchased the tool, and surveyed the key information system personnel about their impression. So they sent a questionnaire And the paper-based questionnaire in this case was at the time in which it was not common to have questionnaires by web. Now it is much easier, of course. And they collected information in this way from the people who actually bought the tool. You understand that in this case, people bought the tool. In some cases, you may want to understand, for example, what are the factors affecting the adoption of a certain tool for an open source tool. Okay, so in that case, you have to count the downloads. But how can you know that that person actually used the tool for a long time or not, or just download it for another person, for example? So it's more difficult. Okay, but in general, surveys are appropriate for this type of cases, and also for doing in general market research, because the key thing is that you reach a lot of people. You may reach a lot of people. Conceptual modeling is the final type of inquisitive technique. Basically, conceptual modeling is normally mixed also with activities like actual interviews, okay? Because you ask participants to create a diagram of some aspect of their work. For example, the architecture of the system, or the process, the software process, or the process in their organization, okay? The idea is to bring to light their mental models, and also to better understand the domain, for example, if you want to understand the process, and to better understand the organization, how things work, how information flow goes. Okay. The advantage is that they are easy to collect, because you just need paper and pen, and you can collect the information. And collecting graphical data and expressing yourself through diagrams, as you know, as software developer and engineers, can help you to express things that cannot be said in words. Okay, the system architecture can be expressed just with a picture. System design, the same. And sometimes also relationship, they are easier to represent when you build up a diagram. And developers are in general quite in use in doing diagram. Okay, but the disadvantage is that you require some domain knowledge to interpret the diagram. So you need to have some previous knowledge about the process or the system that you're dealing with to understand its architecture. Okay, and it's very hard to ask people to draw details, and even asking them to create this diagram through a tool is not always easy. Okay, so you have to gather some information. You often have to draw yourself and ask confirmation. Okay. For example, in this example in which my colleagues actually were involved, they wanted to understand the process of the public administration office in terms of tools, actors, and tasks, okay? Because they wanted to re-engineer the process, okay? And they performed some interview with some people. Then they did the diagram. They did the process diagram by themselves. So like, okay, now we are doing this activity, then you produce this document, then this document is passed to this other actor, etc. They showed this diagram to the personnel to validate, and then they tried to reason on the diagram, to modify the process, to understand what was wrong in the process, okay? As I said, conceptual modeling requires interviews or focus groups. One thing is that they are used in practice in companies, but they are not the most frequent thing in research. Okay. Okay, work diaries. Work diaries are basically, they require participants to record various events that occur during the day. So basically, you have a form, you give a form to the people, and you ask them, when you are doing a certain activity, you should write down some information about the activity. For example, you want to understand. You want to understand the relationship that these people, how many times these people interact with the boss, for example. Okay, every time you interact with the boss, you just open this sheet, you open this form, and you write down, okay, at 12:30, I spoke with the boss. Okay, or you want to understand how long did it take, how much time did you spend on coding, and how much time did you spend on on debugging. Okay, so you write in this form, okay, now I'm debugging, now I'm coding, and impressions, for example. Okay, in some cases, you may want to do random work diaries. So basically based on a certain time, or random in the sense that you just set a time in which these people have to write down what they're doing. Okay. The advantage is that you can report and record record the events, ask them to record the events in the moment in which they occur. Okay, why this? Because if you interview people, the people will tell you what they think after an elaboration of the event, after discarding what they consider not relevant or not worth saying, while the perception of the moment is way different. Okay, so these are good strategies because they allow you to understand really what they are doing in a certain specific moment. Okay. The disadvantages is that you need to convince people to do that, and they may not want to to write down what they are doing because this interfere with their work, and it may interfere even more if you're asking them to do it at specific time. Okay, and so people may tend to neglect to record the information, so you may have unreliable data. Okay. So, for example, I may want to know which are the communication patterns, who do you contact about what in the company. So I ask all the developers to record their communication for 1 week. And in this way, what can I do? I can understand the interaction between team members and interaction between team members and managers, for example. So to understand whether the problems that I might have in a certain company are related to little communication between members of a certain team, or they are related to the fact that there is too much presence or too little presence of the project manager, for example, project manager. Think aloud. Think aloud are another different technique. Instead of asking them to write down in a diary while you're not observing, you ask them to think out loud while performing a task, for example, a programming task. So, for example, you ask them to code, and you observe them, and you ask them, okay, tell me what you are doing. Okay, now I'm coding this function. Okay, now that it doesn't work, so I want to debug it. I'm debugging it, and I understand that it may be related to this the relationship to this other function, my bug. So I'm opening this other function, etc. This is very difficult to get. Okay, and sometimes experiments may occasionally remind them to think out loud because people tend to forget to verbalize if they are really involved in their task. Okay, and they are normally not longer than 2 hours. You cannot ask people to do this thing for too long. The only main advantage is that one of the few ways to test a cognitive model. If I have a cognitive model for debugging, for example, or I want to understand the strategy that developers use for debugging, like in this example, I give a certain piece of software. I can ask them to add some additional feature, and then I ask them to debug based on the error that they get. So in this case, I can understand what is their way of thinking, the way they normally approach this type of problem. Okay, the difficult thing here is really to convince the people and analyze the output, which may be very far from a stable cognitive model. Shadowing and observation. Basically, with observation, it just tells you just do what the name tells. You observe people, you follow them, and you follow them either in a meeting or individually. When they are individual, you normally call them shadowing. Observation is more related to one or more subjects. Okay, one or more subjects altogether, but you normally use the term observation. Okay, These are easy to implement, and you don't need so much special equipment. You just stay in a company or in a certain environment or in a meeting, and you record, you write down diary, and you try to understand what's going on. Okay, but this can be very annoying for people. If so, you need to be really well accepted by the people, and you also need to know the domain very well, because if you go to a working environment that you don't know, with a different process that you've never been before, you see that there is an infrastructure of communication links, but also of practice, of documents, etc., that you really don't understand. So it is very important that you spend some time understanding the domain very well, so possibly also doing some preliminary interviews, and then you do some observation. And the acceptance is the key thing here. So people have to accept your presence. I will give you some example in the lectures, because we will consider not just observation but participant observation that are in the next slide. These are, for example, to monitor. This example tells us one case in which I want to monitor informal communication in a certain group, and I start observing an open development space for a certain amount of days. So there are people in the open space, and I check who is talking to whom, what are the dynamics during, for example, a week, or a month. Okay. Participant observation is joining the team. So you are the researcher and you are observing, but you are also participating. So you join the development team and perform some activities like the others. The main advantage is that this is likely to be more accepted by the participant, and you can create more rapport, and you can give also a contribution to the team. For example, you want to help them in introducing a novel tool, and or in developing some tool that supports them, for example, for facilitating the review of the code. And then in this case, you are helping them, you are present there. Okay. Of course, the issue here is that it is extremely time consuming. It's an additional job, basically. You have to stay there and you have to do your job as researcher, as observer, but you have also to participate. And since you are inside, you may lose your external perspective. So you unavoidably bias the research, although you get more meaty information, more deep information. In this example, you have a researcher that participated in 23 code inspection meetings, so meetings which people were discussing about the code that was developed, were reviewing the code, and he tried to elicit information on how factors, for example, familiarity, organizational distance, and physical distance may be related to how much time is spent on certain discussions and tasks. So this is something that you can do only being present there and observing people. Okay, and also participating as first subject in the inspection activities, because familiarity, organizational distance, physical distance, if you are just observing, for example, the familiarity is something that you may have an intuition about, but you don't really know. Okay, and the role played, you don't really know in detail. So in this case, you need to participate and also know the detail of what is code reviewing, what is code inspection. Okay, these were first degree techniques, so direct involvement on the software engineering. With the second degree technique, basically you have an indirect involvement of the people, and basically there are two types of indirect techniques that are instrumenting system and fly on the wall. This is a name that basically doesn't tell you so much, but they got consistent people recording their own work. Okay. In this case, not much effort is required to the participant, and you don't need to interact with them during data collection. So this is also a good thing, because you don't have to let's say, be present and bias the data collection with your presence. Remember what I said before: if you are an observer or even a participant observer, your data collection is biased, and you unavoidably bias also the person, because if you are present there, they may behave differently from what they would do if you were not there. Okay. So among these second degree techniques, you have instrumenting system. So you monitor developer system interaction during a certain task. For example, you may do eye tracking, cameras, wristband, and add-on tool for logging. For example, as I was telling you before, I may instrument, here is instrumenting systems, but I could be also instrumenting people actually. Okay, like in this example, I can use a tool for logging the system, so to understand the interaction with the for example, with the coding platform, or I can instrument the person somehow, so equip the person with the wristband to understand the variation of emotion during the coding activity. Okay. The advantage is that you have no time commitment for the software engineer, so this is quite good, because basically you can do this experiment without asking too much, and you have accurate information because you have measures. Okay, you don't rely on the impression. Of course, you have no time commitment for software engineers because unless you carry out an experiment. Because if you do an experiment, it means that you put these engineers in a lab, so you have to ask their time, and you often do this not with real professional engineers, but with students. Students are often used as a proxy for professional software engineer in experiments. If you want real software engineers, you often have to go to the company and do something different from an experiment. Okay. The disadvantages is that data are raw and do not have a clear meaning. So you are collecting precise data, but you have to give meaning to this data. And there may be several ethical concerns. If there is time, since it is a very relevant aspect of ethics, ethics is a relevant aspect of empirical software engineering, and especially privacy. I will try to include a module on the GDPR, which is the European law for the management of privacy, that is extremely important now for any developer. Okay, for anyone who wants to develop a system, and there is a lot of confusion, a lot of interpretation. So it is good to have a module dedicated to that. We will try, if we have sufficient time, to speak about this across the lectures. And for example, here, as we have this example here that I was giving you just before. So I want to understand the degree of engagement of the people, and I monitor their engagement with this wristband that is monitoring the heartbeat and other parameters. And I check also with the logger what they are doing in that moment, and then I ask them also to write the degree of engagement every 30 minutes, like with a working diary. So I'm combining. Okay, in this research, I'm already combining different data collection techniques. Because, for example, I want to check to which extent the two measures, sensed engagement and report engagement, are in agreement, and what were the developers doing when they were doing something that was identified as really engaging or not really engaging. Okay, so this means adding on something to people or to the system. Fly on the wall, another method, another second degree method. And with Fly on the Wall, participants are required to record or videotape themselves when they do a specific task. And this does not require so much effort by the participant, and there's no direct interaction. The main problem is that there is a large amount of data, and consider that you may have video and audio recording. Video recording especially are multimodal data. You have audio, you have images, you have a lot of information to analyze, and there is no systematic strategy to analyze this information, and it's not always easy to understand the content of videos, especially if you keep the camera fixed. If, for example, now I go there, you don't see me anymore, but I'm still doing my activity. Okay, and this happens when you do this type of recording, unless a person is there monitoring. But in that case, you make an intervention. Okay, you can use the GoPro and have the movement of the person and monitor the things from their point of view, but it's not easy. Okay, the issue is that it's not easy to do this type of data collection techniques, and they create a lot of data, but they are very informative. Okay. For example, here the example, and I asked the team to videotape each meeting when they do a certain iteration in a Scrum meeting. You don't need to know what is it in a certain meeting. Okay, and I want to see the recording to see the pattern of interactions, again, how people relate to each other and which role are dominant, for example. Okay, finally, third-degree techniques, which are basically called today mining software repositories. Okay, these third-degree techniques require access only to work artifacts, such as source code or documentation, and they are related to the analysis of electronic database of the work performed, or analysis of tool log, document analysis, for example, code documentation and other software-related documents that can be also, as I said before, also app reviews, information related to the user impression about the certain product, and static and dynamic analysis of a system. So this is a so-called software analytics. So I'm checking the content of the code and the behavior of the code. Okay. In recent years, with the development of shared repositories, as I said, there is an emerging field that is called mining software repositories, and that consider all this family of all these different techniques. Okay, and there is even a conference that is quite successful that is called Mining Software Repositories. And if you want to check in the internet, the content from this conference is really interesting, because actually from the analysis of GitHub and other open source repositories, you can gather information about participation of people, typical bugs, and a lot of information about software engineers that you couldn't access before the existence of these things. Okay, so while before we were making a lot of interviews with people, and most of the research was really time consuming in terms of data collection, now you have a lot of data because you have these repositories, and the difficulty is gathering information from all this data. So instead of reaching the source of information, it was very difficult, now we are switching to a moment in which it is difficult to give meaning to a large amount of information. It's a paradigm shift that has been occurring in the latest years. Okay, first, these type of techniques are analysis of electronic database of work performed and tool logs. So I access, for example, to platform for issue or bug reporting, for example, Bugzilla. If you don't know what is it, just checking the internet, and or other version control system or configuration management system. So things that are related to the software process and that are logged in some other tool. The advantage is that I can get a lot of data, and again, like all the third-degree techniques, are independent of the researcher and do not require any work by the developer. So you are not asking them too much. You're just asking them to share their data. Okay. The issue is that you may have a lot of data, too much data, and you don't know much what is the work environment. So work environment might vary from company to company, and you may not need why a certain person has been doing that change request, or why these people are behaving, are leaving this trace in the virtual control system, for example. And another issue is that information is often fragmented. When they do a commit, so when they send a new piece of code or a modification of the code to the repository, they may write simple short lines, in short line, what they've done. But you understand that just if you are really inside the project. So it's not always easy to gather the information. For example, one example can be understand the typical patterns of software evolution. And I look at GitHub and I analyze the change request commits on GitHub, and I check when people are typically performing change requests. For example, when may mean understanding when I have several download, or when may mean when the code reaches a certain size and has been used for this time, or maybe may mean anything, I don't know. And understanding what the typical pattern means may mean also which are the typical sequence of actions, which is the chain of action for the software evolution. Okay. Document analysis. This is another strategy, and consists in the analysis of documents related to the software process. So it can be documents here I mean natural language documents. So documents that are written either in English, in Italian, German, so the spoken language. Okay. So this includes an ecosystem of information that is very large, because code, it has comments, but there are emails between people. There is all the information in Stack Overflow. There may be information in Twitter, in the app review, in the developer's documentation, in the user's manual. So there is a lot of natural language that is surrounding the source code and the language that you use for programming. Okay. The good thing is that written information can often answer why questions. Why, if I observe just the data, I can find relationship between things, but it's very hard to answer why questions. But the issue is that to understand, you are required again, like in the other case, to know very well the context. Today, in the latest years, like in latest now, I'd say almost 10 years, there has been a rising in natural language processing techniques. So techniques, if you look at Google Translate, for example, is incredible. If you look at any tool for manipulating natural language, they made big step forward. But and so this technique can be applied for this type of data, but data are often quite dirty, in the sense that, as I was saying before, like you're not, for example, let's consider developers documentation may be done in a proper way, users manual may be done in a proper way, but the app review can be just a piece of text with several typos and not so informative. Emails, same. Code comments can be not updated with the actual code, so can be a problem. An example is that, for example, I want to understand I want to look at the App Store or Google Play, and want to understand whether the app reviews in the repository contain potential new requirements for my app. I developed an app. I don't know what the people think. The only way to have new requirements is looking at the reviews. But in this case, I can ask some subjects to check about these reviews, identify which ones are actually speaking about new requirements, and check how much they agree. Why this? Because, of course, the opinion of a certain reviewers, the opinion of a certain subject can be different from the opinion of another. So I have to identify the requirements that are identified by, for example, by both the subject. And then maybe I can even improve the process by try to implement a system that automatically predict whether, given a certain review, does this include a requirement or not. Okay. Static and dynamic analysis of a system. And what is this? Is this basically called the universe of software analytics? That means analyzing the source code or the traces generated by running the code, so dynamic analysis. This can help us learn about the design and in a very indirect manner how software engineers think, structure their code, and work. Okay. One might compare programming style or architectural style of different software engineers by analyzing, for example, their use of the constructs and the values of the various complexity metrics. So I can understand by looking at the software, this can give me more information about you and your way of working. Okay. What are the advantages? Again, large amount of data, and there is a set of emerging tools for analyzing this. This is why also mining software repositories is exploding somehow, because you have a lot of open source data and a lot of tools for analyzing this. These are links that you can check. One important one is GHTorrent, and but also the other one, there are libraries for analyzing GitHub. Okay, or other open source repositories. The disadvantage is that source code is not always intuitive, you know, and is often understood just by the person who wrote it. And the dynamic behavior is often even more difficult. Okay, and you always need, for this type of things, you need to resort to automatic support. So while for natural language reviews or any type of document, you resort, if the documents are many, you may use the support of automated techniques, but you can also read the information by yourself. In this case, in most of the cases, since the data are many, you need to resort to an automated support. For example, why I should use this? For example, because I want to check most frequent dynamic error triggered by software in GitHub. I download some representative software, analyze them with outside interpretation. Outside interpretation is a strategy for identifying runtime errors by looking just at the code. And just count which are the typical errors, okay? So that, for example, I can know that I have to look better for developers of open source software for those type of errors. So as a summary, and then we conclude, here I took the table from this paper in which they use this synonym between first degree and first order. So we have first degree technique, second degree technique, and third degree technique. Here you have a complete summary and explanation of when they are used by researchers, and the volume of data that you have to deal with. And there is an interesting column, okay? An interesting column that is also used by software engineers for. So these are data collection techniques for researchers or for software engineers who want to do some research in a company, okay? But there are also techniques that are used by software engineers for their own tasks. For example, surveys, interviews, focus groups, and these first order techniques are used very often for requirements elicitation, which is requirement gathering. And of course, conceptual modeling is also used in requirements, but also for project planning, okay? So you have some of these techniques that are used both for understanding software engineering works, but are also used by software engineers for better performing their work, okay? You can check this paper and see the table. Basically, the thing that I said now in this second part of the lecture are all included in this paper. Okay. This is for today is finished. So see you next Tuesday.